Hello, this is Mr. Collier, and today we're doing the difference of squares patterning task. Alright, so right now we're going to look at exactly what the question is asking us. Then we're going to find a rule, verify it, and justify it. So the task here is to consider the following differences of consecutive square numbers. Okay, consecutive numbers are numbers like 6, 7, 10, 11, two numbers in a row. Okay, so that's consecutive numbers. So remember that, we're only looking at the difference of consecutive square numbers. So here we have 5 squared minus 4 squared is 25 minus 16, which is 9. And then we have 11 squared minus 10 squared is 21. So your task is to determine a relationship between the initial bases. So these are the bases. Okay, the base here is 11, the base here is 10. So these are the bases and the final difference. Okay, so we're looking at the relationship between the bases and the final difference. So I'm going to try to squeeze a table in over here, and maybe we can have, actually let me make a table right here. Okay, so we have bases here, and then over here we could have the difference. Okay, if you want to use variables, I guess we could call this B, and this one D. Okay, actually there's two different bases, so I'll show how to deal with that in a bit. So for the bases here, we're going to subtract some bases. We could start off with 11 and 10 and such. So let's start off with some really small ones. The first numbers that we could use are probably 1 squared minus 0 squared. So 1 squared minus 0 squared, we get 1. And 2 squared minus 1 squared is 3. 3 squared minus 2 squared is, so that's going to be 9 minus 4 is going to give me 5. And then 4 squared minus 3 squared is going to be 16 minus 9, which is 7. And then we have 5 squared minus 4 squared is 25 minus 16, which is 9. Okay, now you can start looking for patterns. Okay, you can do more, you can try bigger numbers. Start looking for a way to figure out the difference just given the bases. Okay.